Thank you. Just presenting about a new piece of service from AWS called AWS Lambda. Apologies for the sensationalist headline, but when I first started working with it, it did feel like it was a bit of a game changer in cloud computing. And this slide definitely does not use left pad, so lawyers, stay away. So who am I? I'm a tech lead at a company called StarCount. We're a young startup, but we've got a bit of a heritage, long story. We do a lot of big data analytics that involves social, market, and customer data, and some physical data and stuff like that. I'm a bit of an accidental node.js programmer. My background is in systems and embedded programming, previously at Nokia and Symbian. So technically, I guess I am a full stack developer, but in a different type of way. So before we start off, I mean, this talk is going to heavily, talk about a technology from AWS. So it would be good to know what AWS is. I mean, are you guys familiar with what AWS is in principle? All right, that's good. Just in case, so AWS is Amazon Web Services. It's just a cloud computing service platform. It has things like infrastructure service, so you can borrow a virtual machine or even a physical machine nowadays, run your stuff on it. And if you want to make things a little bit easier for you, they also provide abstractions over those services so that you can just deploy your code and it will run it. And you can provide scaling parameters and things like that, and it will do whatever you want it to do. Just like the 50th LNUG, AWS is actually having a big birthday, 10th anniversary of, I think it was S3 that was released back in March 2006. So things have come a long way. Obviously, not the only game in town. Lots of other cloud computing platforms out there, like Azure, Google App Engine, even Heroku. And if you remember Parse, rest in peace. So what is AWS Lambda, right? I mean, the official definition from Amazon is that it's a compute service where you can upload your code and the service can run the code on your behalf on AWS. Well, that's actually not groundbreaking or anything like that. I mean, that's what AWS or any cloud provider does nowadays anyway. I mean, you upload a piece of code. I mean, of course, you have to specify a bit, lots of other information alongside your code, like, what the scaling parameters is going to be, how it's going to be run, what the execution environment is going to be, et cetera, et cetera. So if that's not interesting, so the next statement is, after you upload your code and create what we call a Lambda function, this is where things get a little bit interesting. AWS Lambda takes care of provisioning and managing the servers used to run the code. Now, this is where things get interesting in the sense that we're not just talking about uploading code and running it. We're talking about AWS taking the responsibility for basically provisioning, maintaining it, and scaling it, whatever that comes along with it. So it sounds like a bit of a black box, right? And the other statement that they make is you can use AWS Lambda as follows: as an event-driven compute service where Lambda runs your code in response to events. So that's interesting. That means the piece of code that AWS runs on your behalf, auto scales and stuff like that, can be triggered by different types of events. And as a compute service, you run your code in response to HTTP requests, which is more like a traditional thing, right? You've got a piece of code, and you can manually invoke it. I mean, you can use REST API or whatever. But before we go any further, a bit of notes from history. Right. If you're old like me, you probably remember, less than 30 years ago, Spellchecker actually used to be a major feat in software engineering, right? We are talking about dealing with tiny machines with really limited amount of RAM. If you're lucky, you'll get disk space, like a floppy drive or whatever. 8086 CPU. I mean, horrendous times, right? Because you just couldn't code naturally, right? You couldn't stick in 250,000 words, maybe, in a hash table, and then just look it up as your spell checking move, right? That wouldn't work. Programming required a lot of specialization, skills, knowledge, barrier to entry was high, blah, 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 right? 30 years later, I mean, freaking left pad, had 11 lines of code, and people were so lazy they couldn't even, be bothered to write, those 4 lines that pad some, random string. But, this is what it is. We're just making progress, tremendous progress. Unthinkable progress in some ways. Apart from front-end development, maybe. That's still fucked. Sorry, apologies to any front-end developers out here. Similar trends in cloud computing, obviously. Back then, there were in-house data centers, proprietary hardware architecture, people like sysadmins and DBAs. I know this probably still exists, but not as many as they used to be. Obviously, monolithic architecture, lots of interdependencies and things like that. And obviously, this wasn't by choice. It was, on the fact that it didn't really have infrastructure or hardware or anything like that that would support, a clean, separated modular architecture. That is how it was. And now, obviously, you've got, infrastructure, platform, and services. They've all been abstracted. You hear these words like IaaS, PaaS, and SaaS. I don't know why they don't have AS, but never mind. You've got on-demand resource allocation and deallocation, which is scaling, which is really powerful. You've got containerization in form of Docker, not traditional virtual machines, which take up a lot of resources just to boot up, shut down, blah, blah, blah. And obviously, a huge focus on creating stateless, modularized architecture. Microservices, really. So, AWS Lambda is simply a response to the current trends in cloud computing. Someone didn't just go to bed, wake up one day and thought that, this would be a brilliant idea. This was coming. Even back in 2004, I was involved in an internal project in Nokia, which actually was looking at, how we can containerize and modularize pieces of software so that we can run them independently in a stateless manner. But obviously, doing it takes a lot of effort and time, and that's where companies like Amazon came in. So what does, this whole trend focus at? What does something like Lambda focus at? It focuses on the code, not infrastructure. We are programmers. We are good at writing code. We're not DevOps, we're not sysadmins and things like that. I mean, if we are pushed enough, we probably can do some of that stuff, but we'd rather not, right? And then you've got all this complexity arising from multi-device, multi-paradigm use cases, right? You've got mobile, you've got web, you've got desktop, and then you have got on the other side of things, you've got Internet of Things, IoT, loads of different sensors sending data in, data out. Then you have got traditional users, hitting your services. So it's all just a huge mishmash of machine, humans, and all those things talking to each other, which means that architecture, just gets more and more complex as we go along. I mean, the hardware and the infrastructure is getting easier, but our life isn't. And then one of the things that Lambda proposes to do is enable the modular event-driven architecture that everyone wishes for. Isolated, stateless entities. Think about NPM modules, right? Stuff that you just put in has a certain amount of input, and when you run it, it gives you some certain piece of output, right? Doesn't depend on anything complicated or states or sessions or anything like that. You invoke that stuff by state and data changes, right? Because that's important. Code has to run because something has happened. We live in the world of reactive programming, right? The old world model of pull-based stuff no longer exists. So as you can see, I mean, a Lambda can be triggered by another Lambda, obviously. Changes to database. If you via notifications, scheduling, and obviously REST endpoints. Now that we've got a bit of a background on the history itself and how Lambda sort of like has been stated by AWS, let's have a quick look at what a Lambda actually is. We've been talking about Lambda functions, automatic provisioning, blah blah blah. So the first thing you do to basically start with Lambda is create a Lambda. Obviously, AWS provides lots of different tools like command line and things like that. Just for the presentation's sake, I'm using the AWS console, which is the GUI. Any sysadmin who comes across this will obviously want to shoot me or commit suicide, but let's not go into that one. So the first thing you do is that when you're in AWS console, you just go in there, you give your function a name. I've called it my Lambda. You give it a description. You specify a runtime. Runtime is important. We're Node.js programmers, so Node.js it is. And then you basically define a Lambda function itself right at the bottom. So more on that, right? So we've been talking about modular pieces of code that AWS will run on behalf of us somehow. So what does this Lambda thing look like? It is actually a function. As you can see, there's exports.handler equals some function. There's two important parameters in there. There's event and context. Event is basically your payload. It's basically whatever event that happened. Event has all the payload parameters that you've sent, or when the Lambda is invoked because of some action, event will have all the necessary information in it. Context is basically information about the runtime and a few other states internal to AWS. I haven't really had a need to use that yet, but it's there should you wish to use it. But the interesting thing about context is that it does provide you with a simple callback called done, where you can invoke it in the standard Node.js API paradigm of error, then data, right? If you call done, null event, your Lambda function exits, and yeah, that's about it. So that's literally the simplest Lambda function you can actually define. So it's pretty interesting, right? Of course, this is just another piece of Node.js code. So you can include NPM modules, this, that, blah, blah, blah. But at its heart, this is what it is. So if you just want to check out how you want to invoke a Lambda function, this is manually invoked, by the way. There are other ways of invoking it. Like we said before, this is event-driven, et cetera, et cetera. So you basically include AWS SDK. Yep. And there you go. I mean, it's not that difficult. So when you call invoke, you basically specify the name of the function. As you saw earlier, we called it my Lambda. There is an invocation type. We'll get to it. And then you specify the payload. It's as simple as that. A bit more on invocation type. There is two right now. One is called event. Another one is called request response. Event is basically fire and forget mode. And in StarCount, we use that a lot. It's basically like, run some piece of code. I don't really care what happens next. Just go ahead and run it. Request response is basically run this Lambda function, but wait for it to finish so that I get notified. So you get, two interesting modes of operation. And both of them make sense depending on what use cases you actually have. Testing, important. The easiest way to test a Lambda function is that when you're logged into AWS console, you can basically set a test parameter to it and simply click a button, and AWS will basically run your Lambda function immediately and tell you basically what's happened. You can obviously invoke it programmatically, and test it programmatically, and even unit test it, because at the end of the day, it's just a piece of node code anyway, right? So you just can directly include index.js or whatever and just run that stuff yourself. A couple of interesting things. as you can see from the output log, the function duration was 28.58 milliseconds. Build duration was 100 milliseconds. So Lambda basically works in the same principle as EC2 on AWS, which is their compute platform. You get, billing durations in 100 milliseconds, and anything after that is billed as you use. So that's really nice because stuff you run on Lambda is built in more or less exact same way you're built when you use EC2 infrastructure. So there is no big surprises in there. It's very easy to calculate how much cost you'll be incurring, blah, blah, blah. I should just say one thing. The invocation logs, like console logs, whichever, blah, 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 are all available in Amazon's CloudWatch, which is their version of logging. So you can have logs in CloudWatch that can then be put onto S3 so that you can analyze it, blah, blah, blah. But of course, you can always view it in CloudWatch if you need to. Deploying the Lambda function. I mean, so far we've been editing code in AWS console, blah. But what happens if I want to, upload my own stuff? That's actually pretty damn easy. Again, the whole thing is you take your source code, zip it up, including the node modules, and just push it to AWS. Right? It's a thing that a lot of Java and .NET programmers might be used to who deploy web apps by zipping them up and putting in some random web servers folder. Couple of things to note. Because of the specific runtime that Lambda uses, if you have NPM modules that have interesting platform dependencies that is not Linux or any weird random combination, obviously you might end up in tricky situations because your code will fail to execute. You'll get a seg fault, right? So that's something that, I mean, if you, for example, ImageMagick, a lot of people use that for image processing. Now, Lambda actually prepackages a lot of well-known node modules so that you don't have to upload like this huge binary package. But I'm just, stipulating situations where if you were to, take a native extension and just put it over there, you might come across situations that, might be unpredictable. Anyway, lots of choices on how you can deploy. Obviously, AWS command line tools, consoles, and there's loads of third-party tools for it. You can always go to that link for additional information about deployment. Okay, that's cool. We know Lambda function, we can invoke it. It's computing on demand, blah, blah, blah. So how about a real use case? Like, why did we get so excited at StarCount about Lambdas? Right. So just like any other sort of like startup, we have our own challenges. We do deal with big data, lots of it. Obviously, which means that we've got lots of different types of processing requirements on the data we have. We've got a small development team, and not everyone is back-end focused. We don't particularly believe in full-stack developers, but that's a different discussion. We don't have DevOps, not yet. And despite all of that, we actually maintain a thoroughly tested code base. That's very, very predictable. That's scalable because, that's what matters. That's what brings in the money. If your stuff doesn't run, if your stuff is unpredictable, it's bound to fail. And we obviously would like to focus on product and not infrastructure, right? And all of this stuff, ensuring that we actually have a life. So that's also very, very important. So Lambda proved to be easily a natural fit for quite a few use cases for data processing we have, right? So, for example, let's take one of the simple use cases we have, which is updating metadata for lots of different social networks. Like, as we started off, I said that, in StarCount, we deal with lots of social data, customer data, and things like that. So we have got, say, hundreds of thousands of social network accounts. So there is, I don't know, Barclays on Facebook. There is NASDAQ on Twitter and things like that. All these accounts, we have to basically make sure that we've got up-to-date information on how many followers they have, how the picture is, so that we can build up graph databases, this, that, blah, blah, blah. So anyway, so a typical sort of like update process looks like this, right? We fetch the accounts that we need to update, fetch the latest data from the social accounts for each of those accounts, write the updated information back to the service from where we fetch the accounts in the first place. Additionally, when updated data has been received, we have to do this metrics calculation, which is a separate piece of activity that updates a few other pieces of information based on how many followers you have, et cetera, et cetera. And then when that happens, again, update accounts to reflect the metrics calculation. Right? And ensure that all of that stuff happens really, really fast. So you can see the challenges in here. Because if you wrote like a traditional batch type operation that chugs along, goes through your accounts, fetches that stuff, does that, maintaining the infrastructure, creating the environment for it, writing the server, the APIs, and things like that, would have proven to be a little bit of a challenging, especially when I had to do it in 2 days. So how did we do that using Lambda, how it works today? So first, you've got, now this is where the interesting thing comes in. We've got a Lambda that's been scheduled on AWS. So one of the triggers for a Lambda function can be a schedule. So a Lambda function can be kicked off on a periodic time interval because of, however you define schedule using the cron syntax or whatever. What it does is that it basically hits this account service and reads the accounts that needs to be updated and then sort of like batches them up. And I'll tell you why we need to batch them up. That's because lots of social networks actually have rate limiting. So you can't just go to Twitter and say, you know what, for these 100,000 accounts, give me all the information in one go. That won't happen. So we have to basically, have parameterized algorithms that know that for Twitter you can make 100 requests at a time, for Facebook you can make 200 requests at a time, blah, blah, things like that. So this Lambda sort of like, takes care of that. Then what it does is that for each batch that's been created for each social network, it fires off a request to create a new Lambda that basically gets those accounts for each of those batches from the various different social network. So you can easily see for about, say, 100K accounts, and assuming, say, you've got like 100 accounts that you can fetch at a time from a social network, you'll be doing like 1,000 lambdas at a time, right? This is exactly what happens. 1,000 lambdas sort of like scale up within millisecond time frame. They start hitting social networks, start getting the data. And once that data comes back to each of those lambdas, they basically update the account service. So we have basically fetched the social network metadata, and we have updated account service. Now, while that was happening at each individual Lambda level, we also basically, once we received the social network metadata, we kicked off a one-to-one relationship. So we've got for each Lambda, we have another set of Lambda that goes off and basically hits the metrics service to basically fetch the metrics data we have so that we can munge it together, right? And when that's happened, so 1,000 Lambda, another 1,000 Lambda, and then finally write back that stuff to account services, right? Any guess how long this takes for, say, if you're processing about 100K records at a time?
21.58 minutes.
You're too optimistic. There's 100. So the whole thing actually takes less than 4 seconds for 100K records.
What's the spend?
Sorry? What's the spend? 0 so far. I'll tell you why. So that was pretty impressive for us. I mean, having all that power, being able to write code in like 2 days to do all of that, and then it runs in 4 seconds, meant that we could incorporate this entire process in one of our build systems, because before we publish data, we need to update some of it. And previously, this, for us, at least some of the jobs we had, would take literally hours and hours to run. It couldn't be built into a build process, but now it is. So this is what Lambda basically brought to us. There's lots of other use cases we have, but I just want to be quick. This is what happened, right? We used a Lambda to kick off a Lambda that kicked off another Lambda. So, of course, I don't work for AWS. I didn't come here to sell you Lambda. There are limits to the system, right? And it's always really, really, really good to know the limits of this cool stuff that you want to pick up and use. So I've been there, done that, so I've been burned. So I can tell you about some of the limits. That's a big one, right? You've got no mechanism as of today to specify the runtime or the underlying machine architecture, right? Which means you're basically stuck with node 0.10.36, one of the highest requested active thread in AWS support group ever, where everyone is +1ing, can we specify the node version? Which brings a lot of pain, because we have code written in ES6 running on 4 or 5, and then we have to write code that's in 10. So we have to maintain different repositories to keep our sanity and things like that, because there are different rules for formatting code, linting it, this, that, blah, blah, blah. Bit of a pain, but I would still say it's worth it. I mean, especially if you're already using 10 or whatever. Obviously, standard AWS Linux image under hood. We did discuss it a bit before, which is talking about non-portable binaries and things like that. That's actually another big one. No mechanism to specify environment variables via process.env. Now, as a lot of backend server-side developers would know, provisioning credentials and artifacts and things like that via process.env is very important, so that your stuff can pick it up in the runtime. But Lambda doesn't have a mechanism like that yet, which is yet another big thread in Lambda. So I'm sure AWS will come up with a solution soon, but it's not there. So you've got few choices. One of them is basically there are NPM modules out there, thankfully not like leftpad, which would, before uploading your code to AWS, inject your process.env variables as a variable inside the code itself and then push it up. So it's not in Git, but it's in the deployed package in AWS, which is a fairly safe place to have credentials anyway. And of course, the other thing you can do, especially if you're invoking Lambdas manually, is that as part of the event parameter, you can actually pass in your credentials in runtime, assuming that you're inside a trusted network, and the Lambdas and your services themselves are running inside a VPC, so that you don't send that stuff over public cloud or anything like that. There's no way to limit concurrency. So the use case we saw earlier, we had like thousands of Lambdas running at the same time, right? Now that's a big problem if you work in an environment where you have to deal with legacy systems. Why? Because imagine you're running 1980s SQL type database, Postgres, for example, which has this model, right? Forking a process for every connection that's made to the database itself, right? And I think a connection in Postgres probably takes about 30 megabytes of RAM or something like that. Now, everywhere on the internet, you'll probably, if you don't know this already, you'll find that people highly discourage creating lots of connections to Postgres, simply because of the fact that per connection, process-based forking model per connection, lots of memory usage. So if you have 1,000 Lambdas and each one of them wants to talk to the database, right? just to read even the simplest of things, suddenly you're just bringing your database down to its knees, right? And I'm just talking about Postgres here. There could be lots of different services where you could have the same problem. Like if you have loads of things hitting your services, creating a storm, literally, for a few milliseconds or a second or two, then it is very difficult, And obviously in companies, enterprise systems where you've got loads of legacy stuff, no one really knows how it works, how it scales, this thing just becomes a bit challenging. So be aware of that. Now, Lambdas, again, I'm sure AWS will introduce some form of throttling mechanism at some point that you can basically say that, don't run 1,000 stuff at the same time, run only 20 or something like that. Or, you basically have to introduce some form of load balancing in front of your legacy services. For example, Postgres has something called PG Bouncer, which actually, buffers connections, incoming connections, and things like that. Cold start can be slow. I mean, at the end of the day, Lambda is using Docker under the hood. If you have a Docker image that hasn't been provisioned before or hasn't been cached by AWS itself, it might be a bit slow. So don't expect 2 millisecond latency when you just called your Lambda function for the very first time or something like that. You just need to make sure that your Lambda containers are hot. If you have critical dependent functionality in your code path, you just need to make sure that your Lambdas are always hot. Otherwise, you will incur a bit of a cost. Lots of other additional limits listed in that link. Things like which version of Linux AWS uses and stuff like that. Ecosystem and the future, important. AWS Lambda actually has been very, very well received. I said that it's currently one of the most popular AWS services, but I think, don't quote on me on this, it is actually the most popular AWS service right now. I don't have the numbers, that's why I didn't say it, but it's definitely one of the most popular services in AWS right now, which is actually a big thing because we're talking about competing with things like S3, right? Other platforms coming soon, because like I said, this is just an evolution in cloud computing, right? This wasn't AWS, going off and thinking, what, this is cool. So Google already has something called Cloud Functions, which is exactly the same thing. Even the freaking function signature looks the same. Azure coming soon. And then you have loads of other platform as a service stuff that's actually built on top of AWS providing similar services. But I never like using that stuff because they cost more money than you really need to pay. Lots of new interesting frameworks and tools in development based in Lambda. There's one called serverless, which they claim to be backend without servers, which is an interesting concept because one of the ways you can invoke Lambda is by creating an API gateway in AWS. So you can literally have API specifications that you can just hit, and it would just run code in Lambda as a response to your API request. So interesting way of doing things. There is also Claudio.js, which is very good in terms of if you want to have a sane deployment model based with, which integrates with your standard CI stuff. I don't know, whichever you use, Circle CI or whatever, even Jenkins. So further reading, a few things. There's lots of additional use cases. Lambda is being used by lots of Fortune 500 companies. Netflix has a huge use case on how they use Lambda to scale a lot of their architecture. Pricing, very important, like someone said. Now here comes the pricing deal, right? Effectively same as EC2, but a very generous free tier. 1 million free invocations a month, right? And 400,000 gigabyte seconds of compute time a month. That's actually a lot. How much are you going to get done in that? A lot. Because, so when I said that we haven't actually incurred a cost, we are actually still in free tier. And yeah, It's worked out pretty well for us. Obviously, we'll eventually have to pay, but given the fact that we would have been paying more or less the same thing had we been on EC2, why not? Support, that's sort of like the forum thing. And that's about it. And if you have any questions.
Where'd you get your quotes from?
I love movies. Yeah.
Do you have like any control over like instance types, like what region things run in, like that kind of thing?
So the question was basically whether we have control over instance types and where we get to the region and things like that where we run our function. So there is not much of a control over the instance types right now. You do have control over how much RAM your Lambda process is going to use. So you can specify, my Lambda is going to take 120 megabytes or like a gigabyte of RAM and things like that. But you don't have control over the burstable CPU performance and things like that, stuff that we're very familiar with if you have worked with AWS. But then again, this is node.js. We shouldn't really be doing hardcore CPU-related stuff. But if you do need to, I'm sure AWS will in the future, start supporting it. In terms of region, absolutely. You can create Lambdas in different regions. You can create Lambdas inside VPCs also now, which is really good. So if you're one of those paranoid companies who wants to keep everything inside and there is no connection out to the outside world, you can do that. So.
You say you shouldn't do CPU intensive stuff with Lambdas or with Node. And Node, it's obvious, but for Lambdas, surely that's a good use case.
It is a good use case, but the thing is, what you have to do is you have to trade off, right? Because the maximum time a Lambda can run for is 30 seconds.
Okay.
So there is a limit on that. But again, it sort of like comes down to the whole microservices philosophy, right? If you have a piece of code that's running for 30 seconds, that means that there is opportunities for it to be taken apart, perhaps, and maybe modularize it to somewhere else. This is definitely not a worker environment. Lambda is not a worker environment. That is what you'd probably use a worker environment for, where you have a fork-based model. You fork processes, and you can run intensive stuff in it. This is more targeted towards things like Internet of Things, where you need to have event-driven things. If you have hundreds of thousands of sensors around the city, which are sending in data that needs to be processed, database needs to be updated. It's actually a very good use case for that.
You could say a few things about Claudia or the other one. I've read about it, but I've never used it.
Right. Sure. Claudia is basically a nice project, that enables you to manage your Lambda functions without having to go through AWS command line tools. And as everyone sort of like knows, Amazon is notoriously bad when it comes down to documentation and tools and things like that. So Claudia is really nice in that respect. You can easily test, deploy, and manage your Lambda functions, using a familiar and easy to understand syntax from the command line using Claudia. Serverless is basically taking Lambda and effectively putting APIs and authentication and things like that on top, so a good use case is if you're a mobile developer, right? You had services like Parse before. There are other services like Parse, obviously, but if you take, they're basically, doing something similar where you have got a very cheap, frictionless mechanism of setting up a backend quickly, giving it APIs and things like that, and then giving it, code to execute on the backend without having to understand much about Lambdas or AWS infrastructure in general and things like that. Oh, sorry, you had.
What about modules that require building, so C and C++ ones?
Yes. So.
Can they be installed?
So this is where the stuff comes in, right? Because your deployment package is effectively taking just a zip file of your node modules folder. You install the node modules locally, right? And then you push it out, and just make sure that your binaries are portable as much as possible. Obviously, you can always, a recommended way of doing it would be, you get a Docker image for AWS AMI, you build your stuff on there so that you know that they're going to be binary compatible, and then push it from there.
But there is no install. You're literally taking it, bunking it down, and then it runs.
Yes, because if you had npm install, then your Lambda invocation might take a while, right? So that's where things get a bit challenging. Yeah.
Thanks for the talk. Not
welcome.
a question, but kind of an amendment. I'd like to promote yet another AWS project. It's called API Gateway.
Yes.
And it's a good mix with Lambda, so you can basically build your API in AWS interface, and then link it to a Lambda, and you have the API server straight out of the box without much development.
Yeah, that's exactly what serverless uses.
Yeah.
It uses API Gateway to basically create a REST interface on top. And the other really good thing about API Gateway, now that we've spoken about it, is that it uses Swagger specification, which I guess a lot of you guys already know about. So you get your familiar YAML or JSON-based API description that you can write down, and it will take it, ingest it, and create APIs out of it, just like magic, but with a bit of a cost associated with it. Yeah. Anything else? All right, thank you.